I'm going to demonstrate the new scrolling game development kit version 2.3. It can be downloaded for free from SourceForge. If you just Google scrolling game development kit 2, it shouldn't be hard to find. It's an open source project available on SourceForge and has its own installer, or you can just copy the individual files to a system. It doesn't really need anything registered on the system, so you can just copy files over. It's developed with .NET. The help file, there's an extensive help file that comes with Scrolling Game Development Kit, and it has been updated to talk about the new lighting features. We'll just take a quick look at some of what's new in the help file. The what's new obviously talks about 2.3.0 and actually everything that went into it. I won't go into that in detail right now, but it's all here. I should also mention the new tutorial, and this graphic sheet properties talks about how you can create graphic sheets that represent normal maps that define how the graphics can reflect light from different directions. But then the tutorial will walk through, the new lighting effects tutorial will walk through a very basic project that touches on all the features that relate to lighting and how to get them into a new project created from scratch. This result of this tutorial will not be quite as nice as what you can get from the template project. There's also a new template project here called Lighting Patterns if you go to File, New Project. And that's what we're going to look at here. And let's see, so the test pattern graphic sheet, you can see, as I mentioned earlier, the NM is the normal map graphic sheet for the test pattern. So we have here are the graphics. They're all white, but they can be colored in the frame editor, or you can color them yourself, whatever. And that will look very similar as far as the shapes and size of the graphic sheet to the normal map for it. So here's a spherical, for example, normal map for the first cell, and if I switch back and forth between them, you can see the normal map corresponds directly to everything in the graphic sheet. So we've got spherical ones, we've got, I don't know what you call that shape, but a wall that has triangles facing every direction, some tubes, and some larger spheres in case you want to divide them up into quadrants. I won't go into too much detail on that. We'll see what they actually look like when we run the project. If you open the frame set editor, you can see how we pulled a bunch of the graphics into a frame set, and we were able to apply coloring to it by changing the modulate blue, green, and red, so that even though everything's white in the graphic sheet, you can apply colors at later stages. The next step would be to take the frames and put them in tiles or sprites. So let's take a look at what the tiles look like. Not a whole lot here. Basically, we're just copying all the frames from the frame set, making them available in a tile set where each tile is 32 pixels wide and 32 pixels high. And sprites, created a few sprites. The player sprite is pretty basic, just that 4-quadrant circle with colors, and notice how the normal map is kind of making that look like a sphere. The edges get a little bit shaded. And so the player is going to be getting input. These are pretty typical for a Scrolling Game Development Kit 2 sprite. Get the input, move, set the acceleration, the velocity according to the input, react to solidity, limit it to 60 frames in case you're running on a really fast system. So the move is going to pick up the velocity from the sprite and move the sprite according to its velocity, reduce the velocity over time with inertia, scroll the screen. If you have a scrolling map, it'll make sure that the sprite is scrolling the map so that it's in the right part of the view. And the new rules are applying lighting. So applying lighting is pretty simple. We just refer to a collection of sprites that represent light sources and send them to the apply lights function, and it will apply all the lighting according to parameters defined elsewhere. The more interesting sprites will actually not be the player sprite, because that doesn't emit light. There are a couple of sprites that do represent light sources, and we can take a look at how that's done. The base class has a new value in it with this version called Light Sprite Base, and that's what the value that we would set on any sprite that we want to act like a light source. So, like any sprite, we have the appearance here in the States tab, and this light source is one that can follow a path and move around and even rotate. So the lighting can point in different directions, so we can even rotate the lights in real time. The other light source is a simple light source, also of course coming from Light Sprite Base, so it can act like a light source. And this one doesn't rotate, it's just simple, but basically the same as the other one. And we've added both these sprites, all the ones that act like light sources, I'm adding to categories, a lights category, so that when we're applying lights, it applies all these as light sources. The reason for creating a new sprite base class called Light Sprite Base is because there are a number of new properties that are going to be defined for light sources visible in the map editor that can be edited. So let's jump into the map editor. Most of the interesting stuff is on this walls layer, and you can see even in editing mode the effects of light sources are visible here. So there are 1, 2, 3, 4, 5 light sources on this layer. Actually, the maximum number of light sources that can be in effect at any one time is 4, so you'll notice this light source isn't actually doing much at the top. This one isn't doing much either, but except illuminating this sphere. I'll explain that in a minute. But only 4 light sources are actually working right now because that's kind of a soft limit. You can go edit that. If we go edit the source code here, I wanted to increase that limit. I could change max lights. Right now it's hard-coded at 4, but just for performance reasons I didn't want to take it too much beyond that without having a need for it. But that can be increased as necessary. But the project is going to demonstrate that you can actually turn light sources off and on so that you can have more than 4 light sources on a map and use them as needed. So the player sprite starts out kind of in the dark over here. And this light source is just the simple one, and it'll move around and illuminate these triangular wall tiles from different directions. Here we're showing the different kinds of normal maps that we saw in the graphics editor. This is the plain old sphere. Bowl is kind of a upside down reverse sphere, so if you're illuminating it from the top, the bottom is illuminated, and if you're illuminating it from the left, the right is illuminated. I don't know if that's really a bowl, but it's the best term I could think of for it. This perimeter shows rear illumination. Notice how, I should explain first, these 2 light sources. The one on the top left is a typical one, kind of closer to the player side of the layer, kind of shining down, and from the upper left on these. So this little area, let's switch to a different tab so I can not have the tile interfering. This little circular area here is being illuminated by this light source. This area down here, this light source is behind the layer, so you can see that the perimeter of this one is actually showing how the back is illuminated. It's not very realistic, it's just I don't know what kind of normal maps artists are going to find useful, so I wanted to create all the different kind of gradients I could think of. So in addition to the typical spherical gradient where you've got the center facing the user and the outsides facing in all those different directions, this one is the center facing the player, and as you go out there's a ring here that's facing sideways, and then as you keep going out these pixels are facing backwards, so it's kind of a weird thing to do. And then this sphere is entirely facing backwards, so this light source here is illuminating the back side of a sphere, and it's showing up here. So again, unrealistic, but who knows what you might find useful. Here's these tubes, the horizontal tube and the vertical tube, and the middle of the tubes they're kind of glass tubes, they're translucent, so I want to demonstrate kind of the alpha channel. This light source is kind of dark around the rim and bright in the center, and that can be accomplished with, as we saw in the graphics editor, you may have noticed there are some transparent pixels in the normal map. We can take a look at here again. That light source uses this normal map, and that's to say where the normal map is transparent is where we want lighting to not affect this. We want the pixels to be drawn at full intensity regardless of lighting, and it's kind of a gradient from full intensity, fully transparent in the center, to fully opaque and fully being affected by other lights around the outside. And here you can see the outside is kind of dark and spherical. So just to demonstrate how you can, it's not a typical thing to do with a normal map, but I figured that would be worth doing with Scrolling Game Development Kit to allow you to have light sources that actually look like light sources. There are probably a number of ways to do that, but that's how I decided to do that. You can also have colored light sources. If I deactivate one of these others so that I can activate that one, which is already active, you can see this light source, the color of it is determined with, similar to what we did with the frames. The modulate alpha, modulate blue, green, and red are determining, the blue and green are taken down a little bit so that mostly you're seeing red here. So that's how you can color light sources in real time too. And the light sources can be, let's turn this back on, active. Light sources can be directed in a particular direction. So the first light source we saw is emanating light in every direction, emitting light in every direction, as is this one. This one is kind of a cone of light, and that's done with some of these new lighting properties that are available. When you have a sprite that's derived from the light sprite base class, it has all these additional properties. So the aim X is relative to the center of this sprite, which direction is the light going. So horizontally 1, Y is 0. Oh, I've got the wrong light source selected. Let's select this one. So horizontally it's facing 1 unit to the right and 2 units down, so it's facing a little bit down more than to the right. And then the Z, you can actually aim the light source toward the layer or toward the player. And right now negative numbers go from the player to the layer. And aperture, this is what determines the width of this cone. So if I take this up to 0.8, you'll see it get narrower, and 0.9 it'll get even narrower, almost invisible there, because when aperture and softness add up to 1, that means you have a single very narrow line of light. So put that back at 7, and the softness determines how much of an edge there is on the light cone. And if I take that to 0, you'll see very crisp edges. Linear fall off determines, combination of linear fall off, quadratic fall off, and constant fall off determine how far the light can reach depending on distance. So if I make this, if I take away the linear fall off and the quadratic fall off and put it all in the constant fall off, notice that it doesn't really diminish over distance. The only reason it would be getting dimmer over distance is because some of the pixels down here are reflecting less of the light coming at such a steep angle, but really there's as much light that's reaching down here because constant fall off means the light does not fall off over distance. So I guess I'll leave that. I'll put that back in. Generally these are supposed to add up to something around 1. So the light Z parameter determines the Z position of the light source. So positive values are on the user, kind of toward the player, and negative values are on the far side of the layer. So if we select this one here, this has a negative Z, which means it's behind the layer, illuminating things from the rear. So let's take a look at what this actually looks like at runtime. There are some things that you cannot see in the map editor. Namely these walls are actually solid to the light sources. And let's actually, before I go into the map editor, I'm going to show how that was done. If I pick this light source, it's got solidity set, lighting solidity. So if you're familiar with Scrolling Game Development Kit 2, you can define a number of different solidities which determine which tiles a sprite sees as solid. So if I go to the solidity section of the project tree, there's one called lighting solidity, and that's what we're using for light sources, what we want light sources to see as solid and not go past. And this has the light solid tile category linked with a solid tile shape, so you can also have uphill and downhill shapes, and lighting will react to slopes as well. But let's just take a quick look. This one only has square light blockers. So look at the tile categories. Light solid. We've just got one tile in here, and it's this one is the one that is blocking light sources. So that's how we determine which tile is going to block light sources. If we go into run the project now, you have to save it first, and it'll build it. And run it in debug mode. So player sprite starts off in the shade. You can see that light source is moving around and illuminating these interestingly shaped wall tiles from different directions. You can see as the light source moves to the left side of those tiles are getting brighter than the right side of those tiles. Moving on. And you notice the player sprite has its own solidity because it's seeing not only those other lighting tiles as solid, but it's also seeing these tubes and these walls as solid. Move over here and we can see as these light sources move around, they're illuminating the spheres from different directions. And because the light source on the bottom is behind the layer, it's not actually illuminating the layer because the normal map for this ground floor tile, whatever you call that, is not reflecting any of the light from behind it. So you can't. That's why you can't see that like you can the one from the top. And here we can see how the walls are affecting the light sources. The light source will emit shadows, or emit light, and as it hits walls it causes shadows to appear. So this lighting template project is just meant to serve as kind of a demo and starting point to show the technical features, how to use them, what they are, how they work, so someone can pick that up and make something more useful out of them. The most useful piece maybe right now is these normal maps, because Scrolling Game Development Kit 2 does not right now have any features built in for editing normal maps, so your only choice right now is use an external editor and import them, or color pick from different parts of a normal sphere to create a new tile, or just cut and paste pieces of existing normal maps. There's other software out there, like there's something called Sprite Illuminator here. If you wanted to export graphics from your project here, you can load the white tile here and export it. I'll just call it white block. And then we can load that into Sprite Illuminator and do things to it, like applying a bevel. You can have different bevel widths, and there's lots of things you can do applying bevels and textures. So if I want to also apply some structure as a texture, I can make it a textured block. So there's lots of other external programs that can do that, and if I then save the normal map for this, I can import it. Export normals as. Bring back this and open the normal map. I can go import graphic, pick up the normal map for that, store it on this. Now these solid walls will look a little different when we run this project. Oh, I've already run it. I gotta quit this first. See, all these walls here are kind of textured now. So hopefully someone can pick this up, use it as a good starting point, and we'll get some more impressive projects soon.